So welcome to our session today. Our topic is quadratic expressions and equations 2. This is a topic in Form 3. We are calling it quadratic and expressions and equations 2 because we already did quadratic expressions and equations in Form 2. So without much ado, we need to focus now, or rather list the main objectives of this topic. So what are we going to be learning exactly in this topic? So the first thing that we will need to learn is a concept which you already did in quadratic expressions 1, which is the concept of perfect squares. So perfect squares. So what is a perfect square? Just but to mention a few things before we go into the details of this. A perfect square is a quadratic expression which can be factored into into identical binomials. Binomial is basically an expression with more than two terms. So you can factor this quadratic expression or equation into two identical binomials. That is what makes a perfect square. For example, if you have x squared plus 4x plus 2, then you can factor that or factorize that into x plus 2, x plus 2. So the identical binomials in that case is x plus 2 and x plus 2. So that is what we are calling a perfect square. The next thing we will need to do is the completing square. Completing square. And that will now culminate in the solution of quadratic equation by completing square method. The other thing we will do is the quadratic formula. Quadratic formula. The next thing we will do is the quadratic curves. We will also do formation of quadratic equations. So these are the main objectives in this topic, and this is what we are going to be going through so that we can familiarize ourselves with what this is all about. So let us start with the perfect squares. So just like I said, a perfect square is an expression which you can factorize into two identical binomials. For example, if you have x squared plus 16x plus 64. If you factorize this, if you can remember what we did in Form 2, in quadratic expressions, for you to factorize this, you must think of two numbers which, when you multiply, you get the product is equals to AC and the sum is equals to B. Now, if you may recall, A was the coefficient of x squared, B is the coefficient of x, and C is this constant, 64. So generally, a quadratic equation takes the form ax squared plus bx plus c. Just a reminder, remember for an expression or equation to be called a quadratic expression, then the highest power must be 2. So in this case, this is a quadratic equation because when you look at it, the highest power in this case is 2. If the power is more than 2, for example, although we will do that one later, if the highest power is 3, for instance, that becomes a cubic function. If the highest power is 1, then that becomes a linear equation. You already did that in gradient and equation of a straight line. So looking at this, if you were to factorize this to see if you're going to get a perfect square, then A is 1, C is 64, so the product is 64. Then the sum, B, is 16. So we need to think of two numbers which when we multiply we get positive 64, When you add, you get positive 16. So that follows that the two numbers are going to be 8, 8. So if you substitute now for b, you'll have x squared plus 8x plus 8x plus 64. So if you split that into two, so in the first part you have x being common, so x into brackets, x plus 8, plus in the next part 8 is common, so you have 8 into x plus 8. So you now have x plus 8, x plus 8. And it therefore qualifies to be a perfect square because we have factorized that and we've gotten two identical binomials. That is what we're calling a perfect square. But however, there are other versions of perfect squares or other application now question on perfect squares. For example, you can be told what should be added to this x squared plus dash plus 144 to make it a perfect square. So in this case, for you to be able to get this part, you will need now to remember the relationship b over 2 squared is equals to ac. So this is a relationship you're going to use in solving such a question. So in this case, you notice that what is missing is the coefficient, or rather this part b. The coefficient of b, we know is the coefficient of x. So what is missing is b. So b unknown over 2 squared is equals to a, which is 1, times c, 144. So in that case, you have this is b squared over 4 is equals to 144. So you're going to have b squared being equal to, this is a 6, 7, 576. Then you get the square root. So b is equals to plus or minus 26. That is the value of b. So what is missing? It's plus or minus 26. That is how you solve such a question. And this one now can be asked interchangeably. You can be told what can be added. Say for example, x squared plus 26x plus dash. So what must be added to this to make it a perfect square? So you'll still take 26 over 2 squared is equals to AC, and A is 1 times C. Then you get the value of C. So in that case, you're going to get the answer for these parts. And you can go on and on and on in solving that such a question. So much to talk about perfect squares. But that is generally how you need to approach that. So let us now proceed on to the next part, which is completing square. And we will only do this one. We will do completing square and the completing square method simultaneously, because that is always going to be the climax of that subtopic. Solution of quadratic equations by completing square method. So let us use the same example that we had. So you say you have x squared plus 8x plus 64 is equals to 0. So if you want to solve that quadratic equation by completing square method, then this is the steps. So these are the steps. So completing square method. So the first step is to take c to the other side. So you have x squared plus 8x plus dash, since we are taking 64 to the other side, so is equals to minus 64. So after taking 64 to the other side, we now look for the value of c. So we have x squared plus 8x plus, now c will be b over 2 squared. So b is 8 over 2 squared is equals to. So we will take it to the other side. We are going to have minus 64 plus, you add the same thing, so minus 8 over 2 squared. So after doing that, we now group these parts which are squared. So you have x, which is squared, 8 over 2 squared, so we just take 4, then squared, and that should be equal to, you have minus 64, this is 8 over 2, so 8 divided by 2 is 4, squared, you get 16, so you have minus 64 plus 16. So if you take 64 plus 16, that is equivalent to minus 48. So the result here is minus 48, so you can write x plus 4 squared is equals to minus 48. So you notice in this case, you should be, or rather, how you're supposed to solve this is by getting the square root of both sides. But here, you have a negative number. So at our level, we are not in a position to solve these parts until in higher levels. So in that case, that ends there. But that is not actually the correct position. So I want us to take another example and see how we are going to solve that. So say take the example, you have an example like 2x squared minus x minus 6 is equals to 0. Now one thing that you will need to know is that for you to be able to solve a quadratic equation by completing square method, then the first thing is to make sure that the coefficient of x squared is 1. So we start by dividing by 2 all through. So we now have x squared minus 1 over 2x minus 3 is equals to 0. So just like we did in this case, the next step now is to take c to the other side, then look for that c. So we're now going to have x squared minus 1 over 2x plus c is b over 2 squared, and our b is minus 1 over 2. Check, minus 1 over 2. So minus 1 over 2 over 2 squared is equals to 3 plus. So 1 over 2 divided by 2, that is negative 1 over 2 divided by 2, you get negative 1 over 4. When you square that, you get 1 over 16. So when we group this part, you're going to have x minus, not plus because this is negative, 1 over 2 divided by 2, which is 1 over 4, squared is equals to 3 plus 1 over 16, that is 3 and 1 over 16, which simplifies to 49 over 16. So if you get the square roots of both sides, you now have x minus 1 over 4 is equals to 49, square root of 49 is 7, square root of 16 is 4. So we have x, and remember the square root of any number is plus or minus. So x will be, take negative 4 to the other side, it's 1 over 4, plus or minus 7 over 4. So the values of x will be 2, negative 2 and 1 and a half. So if you add this 1 over 4 plus 7 over 4, you have 1 and 1 over 2. 1 over 4 minus this will be negative 2. So those are the two values of x, what we can call the roots of x, or rather the roots of this quadratic equation. So here you will not be able to proceed beyond this point because you're looking for the square root of a negative number. This is called the concept of complex numbers, which we don't do at this level. So this is how you're supposed to solve a quadratic equation by completing square method. Now you should be able to solve a quadratic equation also using the quadratic formula. what is the quadratic formula? So the quadratic formula is as given here. So the quadratic formula is minus b plus or minus the square root of b squared minus 4ac divided by 2a. That is the quadratic formula. So I want us to use this quadratic formula to solve our previous equation and see whether we will get the same answer. So the equation was 2x squared minus x minus 6 is equals to 0. So we want to solve this quadratic equation using the quadratic formula. So unlike in the completing square method, in this case, we don't have to divide by 2 all through, or rather, the coefficient of x squared does not have to be 1. So you can work with it as it is. So we just substitute directly in this formula. So b is negative 1. So minus b is minus 1. So this is always a common trick in the exam, whereby most of the students will just take directly the value of b to be minus 1. But in this case, you notice that it's minus, so that will be positive 1. So we have 1 plus or minus the square root of b squared. b again is minus 1, so minus 1 squared minus 4a. a is 2 times c, which is negative 6, divided by 2a, so it's 2 times 2. So if we simplify that, we're going to have 1 plus or minus the square root of negative 1 squared is 1, 2 times 12 is negative 12, negative 4 times 12 is this is 48. 48 plus 1 positive is 49. So we have the square root of 49 divided by 2 times 2, which is 4. So we simplify that. That is 1 plus or minus 7 divided by 4. So 1 plus 7 is 8. So 8 divided by 4, you get 2. 1 minus 7 is negative 6. So let me just write them. 1 plus 7 is 8 over 4. So the answer there is 2. Then we have 1 minus 7 is negative 6 over 4, which simplifies to negative 1 and 1 over 2. So you notice that we have the same answers: x negative positive 2, and the other value of x is negative 1.5. So that is how you solve a quadratic equation using the using the quadratic formula. So we have two systems in this topic, that is completing square method, quadratic formula so far. But remember, even in Form 2, we did solution by factorization. So that is what you need to remember. So far you have three methods of solving a quadratic equation. The third and the last one for our level is the use of quadratic curves. But before that, I want us to discuss formation of quadratic equations. So formation of quadratic equations. So in this case, in the formation of quadratic equations, you will be given some word problems or statements from which you will be able to end up with a quadratic equation. For example, you're told that the length of a rectangle, so if you have a rectangle here, so the length of a rectangle is 3x plus 1, 3x plus 1, and the width is 3 centimeters shorter than the length. The width is 3 centimeters shorter than the length. So the width will be 3x plus 1 minus 3, which simplifies to 3x minus 2. Then you're told again that the area of this rectangle is 25 square centimeters. So how do you get the area of a rectangle? Length times width. So you have 3x plus 1 times 3x minus 2 is equals to 25. So to form this, you just need to use the first one to expand the second. So you have 3x into 3x minus 2 plus 1 into 3x minus 2 is equals to 25. So you have 9x squared minus 6x plus 3x minus 2 is equals to 25. So like terms, so you have 9x squared minus 3x minus 27 is equals to 0. So in having such, you should now be able to find the value of x. Then from there, you get the dimensions of the rectangle. Remember, this is a quadratic equation, so you can use any of the three methods we've done so far to solve these quadratic equations. And since we've already done that, we will not go to the level of solving these quadratic equations. So you only need to solve, get the value of x, then substitute here. Your values of x will be 3.54. The other one is negative 2.54. So you will definitely disregard this negative value because you cannot have the length of a rectangle being negative. So you will have to ignore this one, or rather disregard. This one is not applicable because it is negative. Length cannot be negative. So having the value of x, you just replace it here to get the dimensions, the length and the width. That is one example of forming a quadratic equation. We can take another example. So another example is that you're told, for instance, in Nakuru County, a dress merchant bought suits at a cost of, so the merchant bought suits at 57,600 from a wholesaler, and she bought the same number of suits from a supermarket. So we have two sellers. We have the wholesaler and the supermarket. So and she bought from the supermarket, it would have cost her for 80 less per suit. But remember, this one is for the total number of suits. This would have enabled her to buy 4 extra suits. So if you buy from the supermarket, she would spend 480 less per suit, and this would make it possible for her to buy 4 extra suits. So taking x to be the cost of a suit, determine the number of suits bought from the wholesaler. So from the wholesaler, the merchant spent 57,600 buying a certain number of suits. So in that case, the price per suit will be 57,600 over, let's say, x. So let x to be the number of suits. So the price per unit will be, or rather take x to be the price per unit. So that if you spend a total of 57,600, then buying one of them, so 1 is equals to x shillings. So you're going to buy 57,600 over x suits. This is from the wholesaler. Then the number of suits bought from the supermarket. We are told that if you buy from the supermarket, she spends 480 less. So here she was spending x. Here she's spending 480 less. So here the price per suit is x minus 480. And she's going to spend the same amount of money. That is, remember, this case is hypothetical. It's if she buys from the supermarket. So in that case, she's going to buy 57,600 over x minus 480 suits. And then this question now goes ahead to say that if you buy from the supermarket, which is at 480 shillings less, you're going to buy 4 extra suits, which means we will now need to interrogate and find out which part is she spending. Is she going to buy more suits or less? So here she's buying 4 extra suits, which means this is greater than this by 4, or rather the difference between this and this is 4. So we take 57,600 over x plus 480 minus 57,600 over x is equals to 4. So in that case, we have a linear equation from which we can form a quadratic equation. So to be able to solve this part, I encourage you to solve this part first, where you first of all you get the LCM of x plus 480 and x, which is x times x minus 480. You do the same thing here. So multiply by x minus 480. So x and x will cancel. X 480 will cancel. So you now have x times 57,600 minus x minus 480 into 57,600 is equals to 4 all over x into x minus 480. Remember, here you're only taking the LCM, divide by this to be left with x. The LCM divided by this, x will cancel, so you're left with x minus 40. So this denominator is still there. So take note of that. So when we simplify that, now when you open the brackets here, we should be able to get 57. So when you simplify the entire equation, you will get 27, 276, 4800 over, open the brackets also here, you have x squared minus 480x is equals to 4. You cross multiply, you form a quadratic equation. So you cross multiply these two, you'll get 4x squared minus 1920 x plus 27. Sorry, you take it the other side. So if you bring this one to this side, it's a minus 276, 4800 is equals to 0. So you have a quadratic equation. So from there, you choose which formula you want to use. Completing square, quadratic formula, factorization. But obviously, looking at these values, the most appropriate formula to use is the quadratic formula. You can choose to substitute as it is or divide all through by 4 first, then replace in the formula. So the values of x will be the absolute value is 2,880 shillings. Yes. So the question was find what? Find the number of suits the dress merchant bought. Remember, x represented the price per suit. So if one suit cost 2,880 and he's spending 57,600, so the number of suits will be 57,600 divided by 2880 to get the number of suits that this person will buy. This is the price per unit, so the number of suits, just take the total amount that you're going to spend, divide by this. Take note that this is an hypothetical case because the question reads if he had spent, or rather if he had bought from the supermarket, he would spend for 80 less and buy 4 extra suits. But the actual case is when the merchant buys from the wholesalers. So that is generally what it entails when it comes to formation of quadratic equations. You need to know what the unknown represents, what the known is, which value will be greater than the other. Like in this case, the number of suits bought from the supermarket which is for 80 shillings less, will be more than the number of suits bought from the wholesaler. So you have to take the number of suits from the supermarket minus the number of suits from the wholesaler to get 4, which is the difference in the number of suits. Because from the supermarket you're going to buy 4 extra suits compared to the bit of or when you buy from the wholesalers. So that is so much talk about quadratic equations, but let me pick one more example, which is a very interesting one. So we only look at the formation stages, then you will be able to complete. You're told that the speed of still water in a river, is 20 kilometers per hour. Then the speed of a boat is x kilometers per hour. So the first part, we are told that when the boat cruises in the direction of the river, it spends 2 hours less than when it cruises in the opposite direction to cover a stretch of say 100 kilometers. So we have a boat which is cruising in still water. The speed of the still water is 20 kilometers per hour. The boat now cruises in, we have the direction of the river and also in the opposite direction. So when it cruises in the direction of the river, it takes 2 hours less compared to when it cruises in the opposite direction. So in that case, we will need to interrogate what is the effect of cruising in the direction of the river and in the opposite direction. So notice that when it cruises in the direction of the river, then it's clearly going to be moving at a higher speed. So what is that higher speed? It is its speed plus the speed of the river. So cruising in this direction, the speed is x plus 2 kilometers per hour. Then cruising in this direction, the speed will be its speed less that this 20 not 2, so x minus 20 kilometers per hour. And cruising in this direction, you take 2 hours less, which means time taken to cruise in the direction of the river is a distance of 100 kilometers divided by the speed, which is x plus 20 hours. That is in the direction of the river. Now, in the opposite direction, the time will be 100 kilometers divided by the speed, which is x minus 20. And as we started by saying, you need to understand which one is greater than the other. So in the direction of the river, you take 2 hours less, which means in the opposite direction, you take 2 hours more. That is what it implies, which therefore means this time is greater than this by 2 hours. So you take 100 over x minus 20 minus 100 over x plus 20, you get 2. Then from that you form the quadratic equation. Then you solve for x, which is the speed of the boat, because that is obviously going to be the question. Find the speed of the boat. That is going to be the value of x. Now with that, we have done the formation of quadratic equations, but there are so many questions which you will definitely get attached. So you form those quadratic equations, solve for x, make sure you identify which one is greater than the other, solve them accurately, and you should be able to master that concept of forming and solving quadratic equations. So much talk about formation of quadratic equations. So the next thing I want us to focus on is the plotting the quadratic functions in a curve or in a grid. So you're going to solve now quadratic equations graphically. So you will be able to plot and solve simultaneous quadratic equations using graphs.
One, quadratic expressions and equations. A quadratic expression is one in which the power of one term is 2. A general quadratic expression is given as ax squared plus bx plus c. In this expression, x squared and x are called terms. X squared is the quadratic term and x is the linear term. A and b are coefficients. A is the coefficient of the quadratic term. It is also called the leading coefficient. B is the coefficient of the linear term. It is also called the linear coefficient. And C is called the constant or the constant term. For example, in an expression like 3x squared plus 4x minus 8, 3 is the leading coefficient, 4 is the linear coefficient, and minus 8 is the constant. Keep these definitions in mind. We will be using them throughout this chapter. In Form 2, we learned how to factorize quadratic expressions where the leading coefficient was 1. For example, x squared minus 3x plus 2. We said you look for two numbers, say a and b, such that a plus b will give us the linear coefficient, and then a times b will give us the constant term. In this case, it would be minus 1 and minus 2. Minus 1 plus minus 2 is minus 3, and minus 1 times minus 2 is plus 2. We then rewrite the expression breaking the linear coefficient into the numbers we've just chosen. And so we will have x squared minus 2x minus x plus 2. And then we factorize the first two, x into x minus 2, and then the other two, minus 1 into x minus 2. X minus 2 is common in both brackets, and so we take one of them. So you have x minus 1 times x minus 2. We've done this before. In this chapter, we will factorize expressions where the leading coefficient is greater than 1. In some cases, we can reduce the leading coefficient to 1 by first factorizing the expression. For example, if you had 3x squared minus 27 plus 24, we can factorize this expression using 3 first. That is 3 into x squared minus 9x plus 8. Notice we are factorizing 3 out and not dividing by 3 because this is an expression and not an equation. If we had 3x squared minus 27x is equal to 24, then we can divide both sides of the equal sign by 3. But in expressions, we don't have an equal sign, and so we factorize. Alright, let's get back to our expression. Now we can factorize the quadratic expression inside the bracket. X squared minus 9x plus 8. We find the two numbers. A plus b should give us minus 9, and the same a times b should give us 8. Those numbers are minus 8 and minus 1. So we rewrite the expression x squared minus 8x minus x plus 8. Factorize the first two, x into x minus 8, and then the other two, minus 1 into x minus 8. X minus 8 is common in both brackets, and so we take one of them. So we have x minus 1 times x minus 8. But now you remember to put 3, and so our answer is 3 into x minus 1 times x minus 8. In certain other cases, the leading coefficient does not factorize. For example, 3x squared plus 4x plus 1. And so we proceed as follows. We find two numbers a and b such that a plus b is equal to the linear coefficient. In this case, a plus b should give us 4. Also, a times b should be equal to the product of the leading coefficient and the constant term, that is a times c. In this case, a times b should give us 3 times 1, that is 3. And so we have a plus b should be equal to 4 and a times 3 should be equal to 3. These numbers are 1 and 3. And then we proceed as usual. We break the linear coefficient so that we have 3x plus x plus 1. And factorizing the first two, we would have 3x into x plus 1 and then the other 1 into x plus 1. That would give us 3x plus 1 times x plus 1. Notice that you could also have broken the linear coefficient as 3x squared plus x plus 3x plus 1. Then we factorize the first two, x into 3x plus 1, and then the other two, 1 into 3x plus 1. And finally we have x plus 1 times 3x plus 1. It's the same thing. Another example, 2y squared plus 21y plus 10. Find two numbers such that a plus b is 21 and a times b is 20. Those two numbers are 20 and 1, or 1 and 20. We rewrite the expression breaking the linear coefficient. We have 2y squared plus 20y plus y plus 10. Factorize 2y into y plus 10, then 1 into y plus 10. And finally we have 2y plus 1 times y plus 10. 8a squared minus 10a minus 3. A plus b should be equal to minus 10. A times b should be equal to minus 24. Those two numbers are minus 12 and 2. Rewrite the expression 8a squared minus 12a plus 2a minus 3. Factorize 4a into 2a minus 3, then 1 into 2a minus 3. That gives us 4a plus 1 times 2a minus 3. Next item, perfect squares. Now 2 squared is equal to 4, 3 squared is equal to 9, 5 squared is 25, and 12 squared is 144. The numbers 4, 9, 25 and 144 are called perfect squares. They have perfect roots, unlike numbers like 10, 3 and 6 whose square roots have decimals. Equally, we have perfect squares in quadratic expressions. For example, x plus 1 squared when expanded will give us x squared plus 2x plus 1. Also, 2x plus 2 squared when expanded will give us 4x squared plus 8x plus 4. The two expressions, x squared plus 2x plus 1 and 4x squared plus 8x plus 4, are perfect squares. For example, show that the following are perfect squares. A, x squared plus 6x plus 9. To do that, we simply factorize the expression. So we find two numbers a and b such that a plus b is 6 and a times b is 9. Those numbers are 3 and 3. We rewrite the expression x squared plus 3x plus 3x plus 9. Factorize x into x plus 3, then 3 into x plus 3, and we shall have x plus 3 times x plus 3, which is also equal to x plus 3 squared, and so the expression is a perfect square. B, 4x squared plus 12x plus 9. Two numbers, a plus b should be equal to 12, and a times b should be equal to 36. Those numbers are 6 and 6. Rewrite the expression 4x squared plus 6x plus 6x plus 9. Factorize 2x into 2x plus 3, then 3 into 2x plus 3. Then get 2x plus 3 times 2x plus 3. That is also equal to 2x plus 3 squared. And so the expression B is also a perfect square. (16x squared minus 8x plus 1). A plus b should give us 8, and a times b should give us 16. Those numbers are minus 4 and minus 4. Rewriting the expression 16x squared minus 4x plus 1. Factorizing 4x into 4x minus 1, then minus 1 into 4x minus 1. We finally have 4x minus 1 times 4x minus 1, which is equal to 4x minus 1 squared. And so the expression 16x squared minus 8x plus 1 is a perfect square. Consider the perfect squares we've just had. X squared plus 6x plus 9, 4x squared plus 12x plus 9, and 16x squared minus 8x plus 1. In a perfect square, the product of the leading coefficient a and the constant term c equals to the square of half the linear coefficient b. That is, a times c is equal to a half b squared. If we expand that, we have a times c is equal to b squared over 4. Let's see whether that is true in our case. The first expression, x squared plus 6x plus 9. A is 1, b is 6, and c is 9. 1 times 9 should be equal to 6 squared over 4. And so 9 should be equal to 36 over 4, and that is true. The second one, a is 4, c is 9, and b is 12. 4 times 9 should be equal to 12 squared over 4, and that is true. The third one, 16 times 1 should be equal to minus 8 squared over 4, and that is 16 should be equal to 64 over 4, and that is true. And so if any of the three is missing, it can be calculated from the relationship. Let's take an example. What must be added to x squared plus 8x to make it a perfect square? And so the missing term is c. From the expression ac is equal to b squared over 4, c is equal to b squared over 4a. That is 8 squared over 4 times 1, and it will give us 16. And so 16 should be added to the expression to make it a perfect square. X squared plus 8x plus 16 is equal to x plus 4 squared, and is therefore a perfect square. What must be added to 24x plus 16 to make it a perfect square? In this case, a is missing. From a times c is equal to b squared over 4, a is equal to b squared over 4c. That is 24 squared over 4 times 16, and that will give us 9. So we must add 9x squared to make it a perfect square. So we would have 9x squared plus 24x plus 16, that is equal to 3x plus 4 squared. Finally, what must be added to 9x squared plus 4 to make it a perfect square? In this case, b b is missing. From the expression a times c is equal to b squared over 4, b is equal to the square root of 4ac. That is equal to 4 times 9 times 4. That is the square root of 144, which is plus or minus 12. We either add minus 12x or 12x. Either way, it will be a perfect square. 9x squared plus 12x plus 4 is equal to 3x plus 2 squared. Also, 9x squared minus 12x plus 4 is equal to 3x minus 2 squared. Next, solving quadratic equations. Now, the difference between equations and expressions is the equal sign. Equations have equal signs, expressions don't. We solve equations, but we simplify expressions. 6x squared plus 5x minus 1 is a quadratic expression. When we add an equal sign, it becomes an equation. In this equation, we can solve for x. Quadratic equations are solved by either factorization where possible or by completion of square. For this case, 6x squared plus 5x minus 1 is equal to 0. We factorize the left hand side. A plus b should give us 5, a times b should give us minus 6. The numbers are minus 6 and 1. Break the linear coefficient. 6x squared minus 6x plus x minus 1 is equal to 0. Factorize 6x into x minus 1, then 1 into x minus 1 is equal to 0. We have 6x plus 1 times x minus 1 is equal to 0. Now at this point, either 6x plus 1 is equal to 0 or x minus 1 is equal to 0. If 6x plus 1 is equal to 0, then x is equal to minus 1 over 6. If x minus 1 is equal to 0, then x is minus 1. Quadratic equations always have two answers. However, in certain cases, the equation may not factorize. For example, x squared plus 7x minus 4 is equal to 0. The left side cannot factorize because you cannot find a and b such that a plus b is 7 and a times b is minus 4. Those numbers don't exist. In such cases, we use completion of square method. Consider these expressions. X squared plus 4x plus 4, x squared plus 6x plus 9, and x squared minus 12x plus 36. All these are perfect squares and their leading coefficients is 1. For perfect squares with a leading coefficient of 1, then the constant term is equal to the square of half the linear coefficient. That is, c is equal to a half b squared. To solve a quadratic equation, we make it a perfect square by introducing a half b squared on both sides. In that case, we must first make the leading coefficient 1. For example, x squared plus 6x is equal to 4. We first add a half b squared on both sides. In this case, b is 6. So we shall have x squared plus 6x plus 6 over 2 squared is equal to 4, and then we add 6 over 2 squared to that side. We shall have x squared plus 6x plus 3 squared is equal to 4 plus 3 squared. We take x squared and 3 squared and put them together. So we have x plus 3, everything squared, is equal to When we finish the right hand side, we shall get 13. To remain with x plus 3, we find the square root of both sides. So we shall have x plus 3 is equal to the square root of 13 is plus or minus 3.61. So if we take the positive, x plus 3 is equal to plus 3.61, it means x will be 0.61. If we take the negative, x plus 3 will be equal to minus 3.61, and therefore x will be equal to minus 6.61. Another example, 3x squared plus 12x minus 5 is equal to 3. We first take 5 to the right hand side, so we have 3x squared plus 12x is equal to 8. Make the leading coefficient 1 by dividing everything by 3. We remain with x squared plus 4x is equal to 8 over 3. Then we add a half b squared on both sides. B in our case is 4. So we shall have x squared plus 4x plus 4 over 2 squared is equal to 8 over 3 plus 4 over 2 squared. That will give us x plus 4x plus 2 squared is equal to 8 over 3 plus 2 squared. We take x squared and 2 squared together. So you have x plus 2, everything squared, is equal to 20 over 3. 8 over 3 plus 2 squared will give us 20 over 3. To remain with x plus 2, we find the square root on both sides. So we get x plus 2 is equal to the square root of 20 over 3. The square root of 20 over 3 is plus or minus 2.58. So we have x plus 2 is equal to plus or minus 2.58. If we take the positive, x plus 2 will be equal to 2.58 and x will be equal to 0.58. If we take the negative, x plus 2 is equal to minus 2.58 and therefore x is equal to minus 4.58. One more, 2x squared minus 8x minus 7 is equal to 0. We take minus 7 to the right hand side. We have 2x squared minus 8x is equal to 7. We divide everything by 2 to make the leading coefficient 1. And so we shall have x squared minus 4x is equal to 7 over 2. Next we add b over 2 squared. B in our case is minus 4. So we shall have x squared minus 4x plus minus 4 over 2 squared is equal to 7 over 2 plus minus 4 over 2 squared. Then we have x squared minus 4x plus minus 2 squared is equal to 7 over 2 plus minus 4 over 2 squared is 4. Then we take x squared and minus 2 squared. So we have x minus 2, everything squared, is equal to 7 over 2 plus 4 should give us 7.5, that is 7.5. We find square root of both sides and we remain with x minus 2 is equal to plus or minus 2.74. If we take the positive, x minus 2 is equal to 2.74, x will be equal to 4.74. If we take the negative, x minus 2 is equal to minus 2.74, then x is equal to 0.74. Next, the quadratic formula. Now, the general quadratic equation is of the form ax squared plus bx plus c is equal to 0. Let's solve for x by completing the square. The first thing we do is take c to the right hand side. So we have ax squared plus bx is equal to minus c. To get the leading coefficient to be 1, we divide everything by a. And so we have x squared plus b over ax is equal to minus c over a. Now we add b over 2 squared to both sides. Notice in our case, b, the coefficient of x, will be b over a. And so we find a half of that and then we square. So we shall have x squared plus b over ax plus b over 2a squared. That is equal to minus c over a plus b over 2a squared. So on the left hand side, we take x squared and b over 2a squared. So we shall have x plus b over 2a, everything squared, is equal to minus c over a plus, if you expand b over 2a squared, you will get b squared over 4a squared. We can first complete the right hand side. We have minus c over a plus b squared over 4a squared. The LCM of a and 4a squared is 4a squared. 4a squared divided by a is equal to 4a times minus c will give us minus 4ac. And then 4a squared divided by 4a squared is 1 times b squared will give us plus b squared. We can rearrange that to have b squared minus 4ac over 4a squared. So we equate that to the left hand side. X plus b over 2a squared is equal to b squared minus 4ac over 4a squared. We find square root on both sides. The square root of 4a squared is 2a, and that can be completed like that. So we have x plus b over 2a is equal to square root of b squared minus 4ac over 2a. We take b over 2a to the other side and we shall have x is equal to minus b over 2a plus or minus square root of b squared minus 4ac over 2a. We have a common denominator 2a, and so we shall have x is equal to minus b plus or minus square root of b squared minus 4ac over 2a. This is the quadratic formula and can be used to solve the quadratic equations for the value of x. We take an example. Use the quadratic formula to solve 5x squared plus 8x minus 2 is equal to 0. A will be equal to 5, b is equal to 8, and c is minus 2. X is equal to minus b plus or minus square root of b squared minus 4ac, everything over 2a. We substitute in our values. X is equal to minus 8 plus or minus square root of 8 squared minus 4 times 5 times minus 2 over 2 times 5. That is equal to minus 8 plus or minus square root of 64 minus minus 40 over 10. That is minus 8 plus or minus square root of 104 over 10. That gives us 8 plus or minus 10.2 over 10. Minus 8 plus 10.2 over 10 will give us 0.22. If we take the negative, minus 8 minus 10.2 over 10 will give us minus 1.82. Next, solving simultaneous equations. Now, simultaneous linear and quadratic equations are best solved by substitution. For example, solve 4x squared minus y squared is equal to 5 and 2x plus y is equal to 1. Now the first equation is quadratic, the second is linear. We can make y the subject of the linear equation, so we have y is equal to 1 minus 2x. Now we substitute this in equation 1. So we have 4x squared minus y now is 1 minus 2x squared is equal to 5. If you expand 1 minus 2x squared, you will have 1 minus 4x plus 4x squared. Hope you know how to do that. So we shall have 4x squared minus 1 minus 4x plus 4x squared is equal to 5. We get 4x squared if we open that bracket. Minus times 1 is minus 1. Minus times minus 4x is plus 4x. Minus times plus 4x squared is minus 4x squared, and that is equal to 5. So we get minus 1 plus 4x is equal to 5. 4x is 6 and x is equal to 3 over 2. Next, quadratic graphs. Quadratic graphs are obtained by plotting chosen values of y against the corresponding values of x. For example, for an equation y is equal to x squared minus 2x minus 3, we get a table of values for x and y. In quadratic graphs, we need a range of values. For example, in this case, let's take the values of x from minus 2 to 4. We write it as minus 2 less or equal to x less or equal to 4. When x is minus 2, substituting in the equation, y will be 5. When x is minus 1, y will be 0. When x is 0, y will be minus 3. When x is 1, y will be minus 4. When x is 2, y will be minus 3. When x is 3, y will be 0, and when x is 4, y will be 5. And so we plot the points minus 2, 5, minus 1, 0, 0 minus 3, 1 minus 4, 2 minus 3, 3, 0, and 4, 5. Then we join the points with a free hand to obtain a smooth curve. This is the kind of graph you'd expect. This kind of a graph is called a parabola. When the leading coefficient is positive, like in our case, the graph faces upwards. When it's negative, the graph faces downwards. The highest and the lowest points are called the turning points of the graph. Let's now draw the graph for y is equal to minus x squared minus 2x plus 8 for the range of values of x from minus 5 to 3. Table of values. When x is minus 5, y is minus 7. X is minus 4, y will be 0. X minus 3, y will be 5. X minus 2, y will be 8. Minus 1, y will be 9, x0, y will be 8, x1, y will be 5, x2, y will be 0, and x3, y will be minus. We plot these points and we get this kind of a graph. Next, graphical solutions of quadratic equations. Now, we often use the quadratic graphs to solve quadratic equations. For example, in our first graph, y is equal to x squared minus 2x minus 3, we can use the graph to find x squared minus 2x minus 3 is equal to 0 and x squared minus 2x is equal to 2. To solve the first one, we subtract it from our equation for the graph. Y is equal to x squared minus 2x minus 3. Then we rewrite the second equation. 0 is equal to x squared minus 2x minus 3. When we subtract the 2, we'll get y is equal to 0. And so we go to the graph and find the values of x when y is equal to 0. These are points on the x-axis. We have x is equal to minus 1 and x is equal to 3. This is the solution. For the second one, x squared minus 2x is equal to 2. We write it to have 0 on the right hand side. So we have x squared minus 2x minus 2 is equal to 0. Now we subtract it from our equation. And if we do that, we'll get y is equal to x squared minus x squared is 0, minus 2x minus minus 2x is also 0, minus 3 minus minus 2 is minus 1. And so y is equal to minus 1. We find the values of x where y is equal to minus 1. And that is approximately minus 0.7 and 2.7. To solve simultaneous equations using the graphical methods, we simply draw both graphs on the same axis. In simultaneous equations, one equation will be quadratic and the other will be linear. For example, in our second graph, the graph had the equation y is equal to minus x squared minus 2x plus 8. We can use the graph to solve a simultaneous linear equation like y is equal to half x plus 2. We just need to plot the line y is equal to half x plus 2 on the same axis. We choose two values of x and calculate the corresponding values of y. Plotting these points, we obtain this straight line. The graphs intersect at 2 points, so we read the values of x at these points of intersection.
I love that math generally has initially clear and precise answers, that you know when you know it and you know when you don't know it. As you get farther on in it, the answers are not so clearly in the back of the book, but initially math has answers, clear answers. Sometimes they're hard to find, but that clarity. The second thing I love about math is it's a puzzle-solving kind of, if I can figure it out, and the joy of figuring it out, the kind of sense of accomplishment, the sense of excitement when you get it, the challenge of trying to get it. It's that puzzle-solving kind of thing that I really, really like.